Though we work with A values and B values differently, class example 1.32 is rather similar to class example 1.31. I encourage you to pause the video and give it a try before you advance. Here, we're given another piecewise function, y equals f of x, and we're asked to construct a mapping rule to sketch the graph of g of x equals f of 3x. We need to remember that a b value, which is to say a coordinate in front of x, has a reciprocal effect. So when we see 3, the effect is that we have a horizontal stretch by a factor of 1/3 relative to the y-axis. So let's label the points on our graph and multiply each x coordinate by 1/3. We'll note this time that our invariant point is located on the y-axis. Now, in this graph, our invariant point actually passed through the origin, so it is simultaneously a y-intercept and an x-intercept. But you will note that there are other x-intercepts for this graph, and they have changed position. So it is in fact the y-axis that is our stretch axis, and that's where we find our invariant points. In order to discuss the domain and the range, let's first find the domain and range of the original graph. We had a leftmost point with an x-coordinate of -9 and a rightmost point with an x-coordinate of 12. The lowest point on the graph was in fact that end point on the right with a height of -6, and the highest point had a height of 3. Now, can you figure out what's going to happen here? We have a horizontal stretch by 1/3. Note we've had no vertical transformations, so we expect our range to remain unchanged. But for our domain, we're going to take our minimum x value of -9 and our maximum x value of +12 and multiply both by 1/3. This gives us -3 and +4. As a quick check, you can note that the original graph, going from -9 to +12 horizontally, had a width of 21 units. Now, going from -3 to 4, it has a width of only 7 units. That is 1/3 as wide.